Hello, grade 8, a new lesson in our unit. The lesson is called projection. Okay, this is as an introduction. This is not a lesson to come in the exam, but this is apart from the next lesson, inshallah, which is Euclidean theorem. Okay, let's talk today about projection. This is a very, very easy one. What's meant by projection? Projection means that if you have a thing and a point or something you want to drop, when it falls perpendicular on the plane or on the line, this is the projection. If this point is A and I drop it perpendicular on the line, this point A dash is called the projection of A on the line L. Okay, so if you have a line and you have a point outside the line and I want the projection of point, for example, B, okay, and I have here point C, point D, point E, and so on, okay, and I want the projection of this point. When you draw a perpendicular line from B, perpendicular, this is the point of projection. So E is the projection of B on the line L. It is not D and it is not C because this is not perpendicular. Okay, so projection of a point on a line, if L is a straight line and A and B are 2 points on the line, where A belongs, it doesn't belong, sorry, to L, but B belongs to L, so the projection will be A dash. Okay? Okay, so A dash is the point of intersection of A dash and L. And this is called the projection of A on L. Okay? Now, if I want the projection of B in this example, or I draw a line and this is L, I said if I want A, it's a projection when I drop this point perpendicular, this is A dash, or its name can be any letter. If I have point B on the line, where is its projection on the same line? I want to drop it perpendicular. B, it is on the line, so it will be B itself. So it's projection because it will go where? Nothing. It's on the line. It will not go up and not go down because the perpendicular is the same point. Okay? So projection of a point on a straight line is that the point of intersection of the perpendicular segment from this point and the straight line, where the point intersect the straight line. If the point lies on the straight line itself, so the projection on it is the same point. Is this clear? If it is not a point, if I want the projection of a line, for example, if I have here a line AL and I want, for example, projection of AB line segment on L. It is the same. We said as if each point is alone. As if I want A alone, so I'll drop it perpendicular. For example, name it E, no problem. And this one perpendicular, name it F. So the projection of AB on L is the line EF. EF is the projection of AB on the line L, where the point A comes down perpendicular and point B comes down perpendicular. Okay, let's see our here finding the projection of line segment AB on L. A dash, as you see, it is perpendicular, so A dash is the projection of A on L. B dash is the projection of B on L, so the projection of AB is A dash B dash. Where the projection of C? Drop it perpendicular, so C dash is the projection of C on line L. Let's see this practice now. AB, and I have here L, the projection of AB on L is A dash B dash. What about CD? I want its projection. Take point, then go to the other point, point by point. Okay, look at the line segment as if it's 2 points. Any line segment contains starting point and ending point. Each point, drop it perpendicular. So C, I will drop it perpendicular on L, or yes, L. So it becomes C dash. What about D? D is a point on the line itself, so it will be the same. So the projection of D, it is the same. Write it DC dash or C dash D, they are the same. What about, I want the projection of EF. EF. Projection of E, it is on the point, so the point will not change. Projection of F, take a line perpendicular from the point to the line. Perpendicular. So its name here is F dash. So the projection of EF on L is EF dash. What about another, complete the practice here. I want the projection of, for example, XY. Concentrate here. X is up, it's no problem, up or down from the point to the line. From the point to the line. From X till you reach the line by a perpendicular segment. It becomes X dash. Where is Y? Y is down. Take it perpendicular to L. It becomes Y dash. So the projection of XY on L is X dash, Y dash. What about MN, sorry. M perpendicular, it becomes M dash. N perpendicular, it becomes N dash. What about this line? AB. This line is different than the other. Why it is different? Because this line is perpendicular on the line L. This line segment is perpendicular on the straight line L. If I take point A, this is point B. The line is drawn perpendicular. Okay? Go with A perpendicular to the line. I want to go perpendicular from A. For example, I will reach point F. I name it F. Any name. But if I want to take B, this point B, go perpendicular. As you see, it is on the same line. I'm going on the same line. So they are on the same point. So the projection of AB on L is only 0.1 point. So the projection of a line segment on any straight line, it is a line segment, except for this case. This case, if the line is perpendicular to another line, so the projection is a point, only point. It's not a line, because both points will go down to the same point. Okay? Okay. If I have here, before going, okay, I will say this quickly. The projection of a ray, the same idea. I have A, D ray. A will go down A dash, B, B dash, D, D dash. So the projection of AB ray is the line A dash, B dash. Okay? It is the same idea. Because before going to this exercise, let's take this shape, for example. If I have this line, and if I have, for example, AB, and I want its a projection, we said I will go down. It becomes A dash, B dash. Okay, so A dash, B dash, this line is the projection of AB on L. Okay, so the line is AB. Its a projection is A dash, B dash, line segment. And the relation between them, as you see here, A dash, B dash is smaller than the original line segment, because it was inclined. When it go down with perpendicular, it becomes smaller. Okay, also in this case, the case we have just said, if I have point AB like this, A up and B down, and I want its projection, when this one go down, it becomes A dash, and this one goes up perpendicular, it becomes B dash. So its projection is A dash, sorry, here B dash. So AB is the line segment, and A dash, B dash is its projection. The relation between them, also A dash, B dash, is smaller than AB. It's smaller than the original line. Okay? Also in this case, if I go down and I draw another case, in this case, I have one point up, for example, and one on the line. Okay? And I name them AB. go down with this one perpendicular. So this become A dash. The projection is B will remain as it is because it's already on the line. So the line is AB. The projection is A dash B. B is, it didn't change. So the relation also A dash B, the projection is smaller than the original one. What about when the line is parallel? If I draw a parallel line to the given line, if AB, and this is very important cases, okay, if AB is parallel to the line and you go down perpendicular and go here perpendicular, here B dash and here A dash, the original line is AB, the projection A dash B dash. What is the relation? Is A dash B dash in this case smaller than AB? No, it is equal to AB. So the projection of a line to a given line, when are they equal? They are equal when they are parallel, and it's always come in the choose. If A dash, or if the projection of a line equal the projection of a line equal to the same line, this line segment equal to its projection. So in which case? In the case when they are parallel, when it is inclined by any angle, so always the projection line will be smaller than the original one. Another case, I just said it, when the line is perpendicular. If I have this point L and I have AB perpendicular on the line, and you go down, for example C, so A becomes C, B becomes C. So if AB is the original line, what is the projection on L? The point C. This is the only case you will get at point. And in this case, A dash, B dash, where is A dash, B dash? Nothing, equals 0. There is no line segment comes from this case. Okay? Let's take the exercise here. Concentrate because we will apply what we have just said here. AD parallel to BC, AB equals 13 centimeter, BC equals 5, CD equals 15, measure ACB equals CAD equals 90, as you see here, perpendicular to each other. First, I want here, what did he want? In this lesson, and in the Euclidean lesson, it's not comes like what we studied before, Pythagoras. Get please AC. He will not say AC. Find the length of AC. No, he will write it as this one. Find what? Find the length of the projection of a given line on, for example, another line. AC here means like L here, like L in our exercise here. This is L. When I say the projection of AB on L, maybe I will not name this one L. If this one is named, for example, CD. Find the projection of AB on CD. Okay? Okay, let's go. He wants what? The length of the projection of AB. Let's see AB. AB. This is AB. Look at it very well. I want its projection. What's meant by projection? The 2 points perpendicular on the given line. Where is AC? AC is this line. So please make your line clear. This is your line, you want to project AB on it. So I want the 2 points on this line. Okay? So B will go where? I want from the point a perpendicular to the line given. So perpendicular. It becomes point what? C. The point A, it is already on the line. AB on AC, the same point. So it will remain the same. So he want what? He want what? He didn't want AB. And AB أصلا given. And he didn't want, he will not say it clear. But from writing or getting the projection of AB on AC, you will find that he want what? he wants the length of AC. Why AC? Because A is the same point. B going perpendicular to the line, straight line AC is the point C. So instead of all of this one, as if he is asking you to find AC line segment. Very easy طبعا to get AC now. I want to get AC. Right angled triangle. I have AB 13, BC 5. So AC, since measure angle C equals 90, AB equals 13, BC equals 5. So by applying Pythagoras theorem, therefore AC square, this is a side, so it will be equal the hypotenuse square minus the length of the other side. So 13 square 169 minus 5 square 25. So 169 minus 25, it will give you 144. So therefore AC will be root 144 equals 12 centimeter. So the length of AC is 12 centimeter. Okay? Okay, let's read the next requirement. He wants the projection of CD. Please. CD. Where is CD? He wants this one. On what? On AD. Okay, I will make my line clear. I want its projection on this one. As if this one is L. Okay, but its name here, because this is an exercise, will not draw like this one. It is called AD. I want the projection of DC. Okay, D, it is on the same line, D and D. So he wants D. D what? Go perpendicular from C to the line. Go perpendicular. It becomes point what on the drawing? A. So instead of writing find the length of DA, he is asking you to find the projection of CD on AD line, straight line. I got this 112, and this is right angle. The same steps. I want in a right angle triangle, one side is missing, so it will be 15 square, which is 225. 15 square minus 144 equals 81. 81 under root. So this line is 9 centimeter. Okay? Okay. This is Euclidean theorem. We will talk about it, inshallah, next session. Thank you, grade 8. See you next time, inshallah.